And someone in first was absent as well.
I'm a peach.
Name your own. Okay, here we go. All right, so for the third time, many times in life we are asked to optimize quantities, find the largest or smallest value of some quantity that will fulfill a need. Typical situations: find the route or route which will minimize the time it takes to get to school, build a structure using the least amount of material, build a structure costing the least amount of money, build a yard enclosing the most amount of space, find the least medication one should take to help a medical problem, find the most one should charge for CD in order to make as much money as possible. Okay, all of these situations have something in common. They are all trying to maximize or minimize some quantity. This lends itself to a calculus solution. In every optimization problem, you are always looking for quantity to be maximized or minimized. Okay, I'm going to scoot kind of quickly through these steps, and then as we start to set up some problems, I'll come back and refer to what these steps mean. All right, we're going to assign variables to the quantities that we're given and quantities that we need to find. Sometimes we'll use letters other than X and Y if they make more sense in the problem. Consider making a chart of possible answers. Write a primary equation. That is the thing that needs to be maximized or minimized. Reduce the right side of the primary equation to one having a single variable. If there's more than one variable, then you must write a secondary equation that deals with restrictions or constraints. Take the derivative of the equation, set it equal to 0. If you get more than one answer, make a sign chart. Keep in mind of plausible answers, like time won't be negative. We can't use more fencing than we have, things like that. Be sure to answer the question that is asked. Okay, so let's start, and then like I said, I'll refer back to those steps so you can see what they actually mean. All right, start out with a super duper easy one. You can probably figure this out in your head. Two numbers add up to 40. Find the numbers that maximize their product. Okay, so y'all are throwing around some answers now.
Wait, what does that mean, maximize their product?
Oh, when they're multiplied together.
When you multiply, you get the biggest number possible.
20,
Okay. All right, so but we're going to set it up so that you can see what the methods will involve. Two numbers add up to 40. You know, if you want to use F and S for first and second, or X and Y, I think I'll use X and Y, two numbers add up to 40. Okay. But do I want to maximize their sum?
No.
I want to maximize their product. Okay, so their product would be what?
X times Y.
X times Y. Okay, so the equation that you want to maximize or minimize is the one that we're going to take the derivative of. But I won't take the derivative until I only have one variable. Okay, so this is the primary equation. That's the one I'll take the derivative of, set equal to 0. This is called the secondary equation.
Is that P or D?
P for product. And I'm going to use this equation to get this one in one variable. Okay, is X or Y easier to solve for? Okay, sometimes there will be an easier one, so just sort of be on the lookout for the one that might be easier. Then I'm going to take this quantity and I'm going to sub it in to that other equation. And what that will achieve is now this product equation will just have one variable. So I have their product is 40 minus Y times Y. Their product is 40Y minus Y squared. Okay, so now I have that primary equation, the thing I want to maximize, in terms of only one variable. So I'm going to take that derivative with respect to the variable. So P prime is 40 minus 2Y. Once I take the derivative, I will set it equal to 0.
Why?
Okay, because think about what we were doing on our sign charts, where we made sign charts and we saw where things were maximums or minimums. It was always where that derivative was undefined or 0. So that's basically what we're doing here. Tell me where, if I graph this, where would the max and mins be? Okay, so let me go back to the steps just for a second. All right, so we assigned variables to the problem. We did not make a chart of possible answers. Y'all kind of actually did that in your head. We wrote the primary equation that we wanted to maximize. That was our product. We had to change the right-hand side of that equation to only have one variable, and we did that by using the secondary equation. We took the derivative, we've set it equal to 0. Okay, so let's see how many solutions we get to this. I add 2y to both sides, then y is 20. If you get more than one answer, which generally you do not, but if you do, first of all, see if it's reasonable, if all of them are reasonable, and if they are, then we set up a sign chart. But most often we just end up with one. Okay, so that's our answer for y. Okay, go back and read the question and make sure that we are answering what we were asked. Find the numbers that maximize their product. Okay, well, I only found one number. To find the second number, I'm going to plug that in over here. So x will equal 40 minus 20, x equals 20. So the two numbers are 20 and 20. Okay. All right. Number, Will it always be what? In that particular situation, yes. Okay, a rectangle has a perimeter of 71 feet. What length and width should it have so that its area is a maximum? And what is the maximum area? Okay, on this one, I'm going to take the advice back here that said, when possible, draw a picture. So I have a rectangle. Okay, how do we find perimeter?
2x plus 2y.
Okay, and if you want to use L and W for length and width, you can. Since y'all said X and Y first, I'll use that. Okay, so it says the perimeter is 71. 2x plus 2y has to equal 71. Perimeter is just sum of the sides. What length and width should it have so that its area is a maximum? I want to maximize area, so I need an area equation.
X, Y.
X times Y, or L times W if you were using those variables. That's what I want to take the derivative of. But I have two variables. I want one variable before I take a derivative. So that's where I go to the secondary equation, solve it for one of them, and then we're going to plug it back in. You want to solve for X or Y? Okay. 2x equals 71 minus 2y. What does x equal?
71 divided by 2 minus y.
Okay, what is 71 divided by 2? Is that a terminating or repeating decimal?
Terminating.
Okay, let's go ahead and use the terminating decimal. If it was repeating, I would stick with the fraction. And what is it? There we go. Okay, so I'm going to take this and plug it in here in the place of the y value. So my area is x times 35.5 minus, I totally did that wrong. Let me put that y in the front. There we go. I'll salvage it that way. I was supposed to go in for x. Sorry. Okay. I could go ahead and take the derivative if I want. I would use product rule, but I think I'm going to just distribute first and then take it. Either way will work. Okay, so this is my area formula. That's what I want to maximize. I have it down to one variable. Now I will take the derivative. 35.5 minus 2y. Set it equal to 0. So that's where your maxes and mins will occur, or where it's undefined, but this is not ever undefined. Is it messing up? All right, what's 35.5 divided by 2?
17.75.
Okay. All right, so that is our length or width, whatever you want to consider that. Let's go back and see what we were asked. What length and width should be used, and what is the maximum area? Okay, so here's one dimension. How do I find the other? Plug it in. This is the easiest place to plug it in right here. 35.5 minus 17.75 is 17.7. So basically it's saying make a square region. Okay, so we found the two dimensions. Was it feet? Yeah, it was feet. But now what is the maximum area? Well, now I need to plug that into my area formula. Multiply x times y, and we get 315.0625 square feet. So all of that would be our answer. And that's the max area that we found. Question? All right. Do you remember when I showed y'all the box situation where we had the piece of paper and we cut corners and then we folded up the corners to make an open top box? Okay, so this next problem is referring to that same situation. An open box is to be made from a piece of metal 16 by 30 inches. 16 by 30. By cutting out squares of equal size from the corners. Okay, so each corner I'm cutting out an X by X corner, and then we'll bend up the sides. What size square should be cut out to create a box with greatest volume? And what is that volume? Okay, so we're going to find two answers. What size corner should I cut? And what is the maximum volume that we can find?
No.
No. Because think if I cut, okay, let's look at this one. We'll try to show the people. Okay, here's a little flat tray, right? I can't get a good picture on there. Okay, what if I cut some really big squares from it? These are not going to be the same size, but maybe they'll be believable. So let's say I cut really big squares and my paper looks like that now. So now when I fold it up, it's actually not going to hold very much in that little box. Okay, so, and imagine if I got those squares super close to each other, then it'd be a little bitty skinny box and hold even less. So the volume does change based on the size corner that we cut. Okay, so here's my picture. How do I find what I want to maximize? I want to maximize the volume. How do I find volume?
Length times width times height.
Okay, length, width, height.
So 16 times 30.
Well, wait, hang on.
5x.
This was 30 to begin with. But what did I do?
Subtracted x.
I cut x out of both sides.
So minus 2x.
So how long is this?
30 minus 2x.
There we go, in unison even. Okay, this was originally 16, but I cut x from here, so how long is this?
16 minus 2x.
Okay, how tall is the box?
X.
Whatever I cut from the corner, because that's what folds up and creates the height there. So let's list all these. I don't know which one you want to, I'll call this one width. Width is 30 minus 2x. Length is 16 minus 2x. And the height is x. Okay, so volume is what I want to maximize. Volume is length times width times height. All right, so I've got to multiply all of these things together. Okay, I already have an equation with one variable, so I don't have to worry about that. I just need to take the derivative. I'm going to distribute first and then take the derivative. Okay, let's compare when you get done.
What was it?
I was like, I don't usually hear the train whistle. Look it. Awesome. Okay. Nope, disagree?
Never mind. I thought you were taking derivative.
You're good?
back.
Okay, yep. Now I'm going to take the derivative. So 12x squared minus 184x plus 480. Ooh, does anybody want to try to factor that? I don't either. Does 12 divide into everything? I would if it did. Okay. Does 6 divide into everything? All right, I'm not going to do it then. I'm going to set up quadratic formula. I know from last block it does factor, so if you're just like, by golly, I'm going to figure this out, factor it, it will factor, but I'm going to do quadratic formula. There's my negative b, plus or minus square root.
All over 2a.
All right, I'll get that in there. There we go. B squared minus 4ac. That is something you need to know. It comes in handy. Okay, so let's plunk away on our calculators and see what we get.
What adjective did you just use?
It was a verb. Plunk.
Sorry, that's what I meant.
Plunk.
Sorry, I don't have any lit classes right now. Miss Campbell, do you know the 13 virtues of Benjamin Franklin?
I don't. Do you?
Yes.
All 13?
Number 1, hit me with
Your best shot?
silence.
Silence is golden.
No, that's the second one. I forgot the first one. Maybe like temperance. Temperance and silence, then humility, and then industry.
And then some others. Okay, let's practice that. Let's practice that silent one for a minute.
And then number 3 is don't get fat. It is.
Avoid gluttony.
No, it's literally don't
Oh,
eat, or else
okay.
you'll be fat. And
All
I hate
right.
fat people. He said that.
Oh my gosh. Okay, shh, refocus. All right, so I got 2 answers. Am I going to set up a sign chart? Are they both viable?
Huh?
Why? But what if they're both possible, and then I'll compare the 2? What, Kenny? I am cutting it out. That's the size of the square.
Oh, I get it.
What?
Wait. Well, wait. You can't cut out a 12. You can't have.
Why?
Oh,
No, I get it. Because 12 plus 12 is not 16.
The 16
minus 2x, you can't have that. It'll be not there.
Whew. Okay. Yes. All right. If the shortest side is 16, can I cut 12 off of each end? No. It would work on the 30 length, but not the 16. So the 20 is an extraneous, the 12 is extraneous. It doesn't make sense in this situation. So we ignore it and just use 10/3. So Back to the question, what size square should be cut out?
10/3.
Okay, the square should be 10/3 inches by 10/3 inches. That's the length and width of the square. And what is the maximum volume? Plug it back into the original. Now I can plug it back in where I had all the parentheses, or I can plug it back in where I distributed everything. It does not matter. Use your 10/3. Don't use, because that's a repeating decimal. Don't use a decimal for that. Use 10/3. That's what?
I'm done.
She stood up to say it too. I like the enthusiasm.
I got 725.95.
I would probably use decimal for my final answer. Oh shoot. Oh well, I already started. I didn't need to use that step. Yes. Yes. What's wrong?
He asked if he could use that.
Oh,
Yes.
I thought he was just saying. I was like, what's wrong? Okay, got it. All right, did y'all get that answer?
Yes.
Okay.
Hold it.
725.925 units.
Inches.
Yep. Question. Yes.
So if we do all this, and we just assume that, like, the answer we get is going to be the most you can have. Like,
Yes. Yes. Because what's the minimum volume? 0. I could cut a corner of 0 and not even have a box, not have a height. So my smallest volume is 0 there. So we would assume that this will give us the maximum.
Not just a word.
Okay, so let's say, shh, y'all listen. Let's say that this answer was 5, which would be a feasible answer. Then I would set up a sign chart with the 5 and the 10/3, figure out where the derivative is positive and negative, and then picture, increasing, decreasing, and figure out which one is higher, which one is lower, which is the min and max.
Is there another one that you put in the equation and still work? It's just on the maximum.
In this case, I could cut any amount other than that and get another volume. It just wouldn't be as big as this. Okay, and if you're skeptical, try 3. Let's say we cut a 3-inch square. If I plugged, let's see if I can type this in quickly. 3 times 3 cubed is 27. Minus 92 times 3 squared is 9. Plus 480 times 3. That's my volume. Ooh, it's close, but it is smaller. Okay, so yeah, there are all kinds of other size squares we could cut, but they would not exceed this volume here. Okay? It does seem kind of simplified, like too simple to be accurate, but it is. Okay, now this is the simplest kind of situation we can have when they give you the equation. A trucking company has determined that the cost per hour to operate a single truck is given by C of S, where S is the speed that the truck travels. S is speed. At what speed is the total cost per hour a minimum, and what is the hourly cost to operate the truck? What are we minimizing? Cost. We want to minimize cost. So I need to take the derivative of the cost equation. Well, here's my cost equation. I don't even have to come up with it. I just need to find the derivative and then set it equal to 0. Okay, derivative would be what?
0.0002 s minus 0.01.
There we go. Okay, set it equal to 0.
X equals 50.
Okay, did y'all get 50 also? Check and make sure. 50 what? What did I find? What does S represent? The speed. So miles per hour. Okay, so at what speed is the cost a minimum? 50 miles an hour. So the truck should drive 50 miles an hour to minimize the cost. What is the hourly cost to operate the truck? How do I find that? Plug it into C. I want C of 50. Did y'all get 11.75? Oops.
I got 11.75. I got 1.7. I got that.
Anybody else?
I got 11.75.
Okay. So that's cost, so it would be dollars. Per hour, because it's the hourly cost. Question? 12 even? You're plugging it in here? Go back and check your number of zeros. Did you have 3 zeros there? And 11 even? Okay. Yeah, 11 even. How are you doing this? It's like when you check out at a store and it's like, that'll be $52 even. You're like, what? Did something mess up? Because that's what weird.
If you go to Hardee's and you get a sausage biscuit combo with medium Dr. Pepper, it's $7 even.
Even? That's so nice. I was pumping gas the other day, and it stopped on like $42.96, and the gallons were almost an even gallon. And I wanted to make both of them like end in zero, but I knew it wouldn't work, so I didn't even try. I thought, there's no way, and then I'll just be mad.
The dollar sign triple the gallon.
Roughly. Okay, last example. The other pages is where you'll find your homework. Other pages are where you will find your homework. A rectangle is inscribed under one arch of y equals 8 cosine 0.3x, with its base on the x-axis and its upper two vertices on the curve symmetric about the y-axis. What is the largest area the rectangle can have?
50 square meters.
Wow. If you are right, I'm going to be super impressed.
You already know he's right. You did this an hour ago.
All right. I can't remember what I did 10 minutes ago. All right. Let's type this in because I don't know what this looks like. Do you?
Sorry.
I just threw out numbers. Let's see if it works.
8 cosine 0.3x. Okay, so we know what cosine looks like. What does 8 do to the graph? Amplitude. And what does 0.3 do? Changes the frequency, and we will see that it will stretch it out. Okay, so here's our curve. This is the situation. I want to place a rectangle underneath this so that it's sitting on the x-axis and its upper vertices are on that curve. Okay, that's a picture of the situation. So let's transfer that to our paper. Okay, here's my cosine. Where's cosine at up here at the top? 8. So I know the rectangle is going to be shorter than 8. Okay, and it's symmetric, so I have equal amounts to the left and to the right of the y-axis. Everybody good with that? Yes.
I think I get it. I don't know.
Okay, how wide is this?
Something.
Something. Okay, that's a good answer, actually. We don't know, do we?
X.
Oh, wonderful. Let's say that that is just x0 there. Then what is this ordered pair? Okay. All right, so how wide is that base?
Absolute value of
Yeah,
x
that's
times
low.
2.
2x.
2x. You've got x over here. You've got x over here. 2x is the, we'll call that width. But, okay, so yeah, if I said how far apart are 8 and negative 2? Yes, because you would say 8 minus negative 2 becomes 8 plus 2. So x minus negative x is x plus x, which is 2x. Okay?
So you don't need
You
that.
take your bigger minus your smaller, and you'll get a positive here. Okay, here's another question for you. How tall is it?
Y. 2.
Whatever y is, right? Whatever that y coordinate is. Guess where the y coordinate is? Whatever I get when I plug x into that. So the height is 8 cosine 0.3x. Now, if I knew what x was, I would plug that in and I would have a numerical height. But until I find x, I just have to leave it like that. Does that make sense?
Sure.
Okay? So, I want to maximize what? Area. How do I find the area of this lovely thing?
Times width.
Okay?
Times height times width.
2x times 8 cosine 0.3x. Okay, I only have one variable, so I don't have to worry about a secondary equation of any type. I'm going to take the derivative of this. What will I use? Okay. All right. 2 times 8 cosine 0.3x plus 2x. What's the derivative of 8 cosine 0.3x? Negative 8 sine 0.3x times 0.3. Chain rule there.
I don't know what we did. Every time I learn something new, it's easy, and then you always add.
All right, let's see. I can make that 16 cosine 0.3x. I can make that, what's 2 times 0.3 times negative 8. Can I multiply all those together? I'm multiplying this and this and this together. Just to get a simpler term.
Negative 4.8.
Negative 4.8.
Yep.
All right, so we're going to set this bad boy equal to 0.
Wait 1 second.
Does anybody know where that equals 0? Yeah, me neither. So what can we do? Not leave it.
Yeah.
Put it in the calculator. Okay? So, yeah, that's not something we would just know. So we're going to type it in the calculator. How do I find where it is 0 in my calculator? And what will I be looking for? Zeros. Yes. Where something is equal to 0 are your x-intercept. That's why we call them zeros, because it's where the function is 0. So let's see what this looks like and find the zeros. Where? Not what I was expecting, but okay. All right, so what is it we're looking for? Zeros. Clearly that's symmetric, right? So really I could find either one of them. Go to second, trace. That's your handy dandy calculate menu. I want zeros. And for these you have to do the left and right. So let's see, find that cursor. There it is. All right, that's left of it. That's right of it. 2.867. Okay, so let's see how we need to answer this. What is the largest area?
2 times 2 would be the width. 2 times that would be the width.
Okay, don't we have an area already set up right here? Yeah, so we could just plug it in there or go back up here and plug it in both. So my area will be, I'm going to put area evaluated at 2.867 will be. What'd y'all get?
50.
29.95.
Okay, 29.925. And I don't think we had units in this, did we? No. So if you really wanted to say square units, you could, but you don't have to.
I might not be wrong. It could be 50.
You said
meters.
50. You were...
Meters.
Oh, okay.
I said meters.
Oh, okay.
This could be meters. This could be inches. And multiply by 2.
Maybe round. A lot.
If we round up to the nearest 25, you'd be right. No, actually, we wouldn't.
Yes, you would.
That nearest 25 would be 25.
Oh, wait. If you round to the nearest 50.
50, yeah. Okay, we'll go there.
Yeah.
Okay, any questions on that
I'm
one?
not getting the right answer.
You're not? Did you leave out an X this time?
What do you think?
Here's mine. See what you have and don't have.
Is it separated 2 times 2.827?
Okay, while he finishes that, your homework, turn the page, there are 9 problems. Your homework is to do 7 of them. You choose which 7. I might go through and just try the ones that I
get 45.
know right away how to do, and then go back and pick up the rest.
I have a test. I'm trying to follow, but my brain is